Welcome to another amazing installment of AP Computer Science. One of the advantages of object-oriented design is that it allows a programmer to create a new data type that is reusable in other situations. When designing a new class, three components must be identified: attributes, behaviors, and constructors. To determine attributes of a class, look at the nouns associated with that object. To determine the behaviors, look at the verbs. Let's consider a checking account at a bank. The account would need to record such things such as the account number, the current balance, the type of checking account that it is, and etc. These would be the attributes of the checking account. It would also need to be able to do certain actions, such as withdrawing or depositing money. These would be the behaviors of the checking account. Finally, the checking account object needs to be created in order to be used, so a class must define how the creation process works. This is accomplished with constructors. In this section, you will learn how to create a simple class that describes the behaviors of a bank account. Before you start programming, you must understand how the objects in your class behave. Operations that can be carried out with a checking account can be accepting a deposit, drawing from the account, and getting the current balance. In Java, these operations are expressed as method calls. For example, assume we have an object checking of type checking account. Here are the methods that invoke the required behaviors. These methods form the behaviors of the checking account class. The behaviors are a list of methods that you can apply to objects of a given class. To the client, an object of type checking account can be viewed as a black box that carries out its methods. The programming concept of not needing to know how things are done eternally is called abstraction. Once we understand what objects of the checking account class need to do, it is possible to design a Java class that implements these behaviors. To describe object behavior, you first need to implement a class, and then implement methods within that class. Next, we implement the three methods that have already been identified: deposit, withdraw, and get balance. What we are doing here is not real code and wouldn't actually do anything. However, it is useful to lay out what your class will look like. When we use a mixture of English and Java to show what we are doing, it is called pseudocode. In the example, implementation of methods is left out because we do not have all the information that we need yet. However, we can still write out what the methods will do in pseudocode, so it becomes easier to see how everything will fit together. The process of starting with a very broad concept or outline and working down to smaller and smaller details is called top-down design. The method header consists of the following parts. An access specifier controls where the method can be accessed from. The method should be declared as public if the method needs to be accessed by something other than the object containing the method. If it should only be accessed within the object, you should declare the method as private. The return type of a method, such as double, void, or drawing tool. The return type is a data type that the method sends back to the call of the method. This can be anywhere from a primitive data or any object in your class knows about. To indicate that the method does not return a value, you use the keyword void. The method name needs to follow the rules of identifiers and should indicate the method's purpose. The parameters are an input to the method. The deposit and withdraw methods of each have one parameter, the amount of money to deposit or withdraw. The type of parameter, such as double, and the name for each parameter, such as the amount, must be specified. If a method has no parameters, like getBalance, it is still necessary to supply a pair of parentheses behind the method name. Once the method header has been specified, the implementation of a method must be supplied in a block that is delimited by braces. The checking account methods will be implemented later. Before any code can be written for behaviors, the object must know how to store its current state. The state is a set of attributes that describes the object and influences how an object reacts to the method call. In the case of our checking account object, the state includes the current balance and account identifier. And each object stores its state in one or more instance variables. An instance variable declaration consists of the following parts. Access specifier tells who can access the data member. Instance variables are generally declared with the access specifier private. That means they can only be accessed by methods of the same class. In particular, the balance variable can be accessed only by deposit, withdraw, and get balance methods. The type of the variable and the variable name are also needed. If instance variables are declared private, then all external data must occur through non-private methods. This means that the instance variable of an object are hidden. The process of hiding the data is called encapsulation. Although it is possible in Java to define an instance variable as public, it is very uncommon in practice. For example, Because myBalance instance variable is private, it cannot be accessed from outside the class. However, the public getBalance method to inquire about the balance can be called. Now we know how the objects store its state, we can provide the implementations of the methods of the class. The implementations for 3 methods of checking account class is given below. The implementations of the methods is straightforward. When some amount of money is deposited or withdrawn, the balance increases or decreases by that amount. The getBalance method simply returns the current balance. A return statement contains the value of a variable and exits the method immediately. The return value becomes the value of the method call expression. The final requirement to implement the checking account class is to define a constructor, whose purpose is to initialize the values of instance variables of an object. To construct objects of the checking account class, it is necessary to declare the object variable first. Object variables, such as checking, are references to objects. Instead of holding the object itself, a reference variable holds the information necessary to find the object in the memory. This is the address of the object. The object identifier checking does not refer to any object yet. An attempt to invoke the method on this variable would cause a runtime null pointer exception error. To initialize the variable, it is necessary to create a new checking account object using the new operator. Constructors are always invoked using the new operator. The new operator allocates memory for the objects, and the constructor initializes it. The new operator returns the reference of the newly constructed object. In most cases, you will declare and store a reference to an object in an object identifier on one line as follows. Occasionally, it would be repetitive and unnecessary to create an object identifier. If the purpose of creating an object is only to pass it in as an argument, you can simply create the object within the method call. For example, when creating drawing tool objects, you are providing a sketchpad object and you do not need to create an identifier for that sketchpad object. Constructors always have the same name as their class. Similar to methods, constructors are generally declared as public to enable any code in the program to construct new objects of the class. Unlike methods, constructors do not have return types. Many classes define more than one constructor through overloading. For example, you may supply a second constructor for the checking account class that sets the myBalance and myAccountNumber instance variables to initial values, which are the parameters of the constructor. The second constructor is used if you supply a starting balance and account number for the constructing parameters. The number of constructors is based on the need of the client. The implementation of checking account class is complex and given below. Using a checking account class is best demonstrated by writing a program that solves a specific problem. We want to study the following scenario. An interest-bearing checking account is created with a balance of $1,000. For 2 years in a row, add 2.5 interest. How much money is in the account after 2 years? 2 classes are required, the checking account class as developed in the preceding sections, and a second section called checking tester. The main method of a checking tester class constructs the checking account object, adds the interest twice, then prints out the balance.